Lesson 10-1, Sample Spaces. An experiment is a situation involving chance. An outcome is the result of a single performance or a trial of an experiment. The set of all possible outcomes make up the sample space of an experiment, which may be finite or infinite. When they talk about the sample space, they're just talking about what are all the possible outcomes you could have. A sample space that contains a countable number of outcomes is a finite sample space. So that means there's limited number in the sample space that you could get. A sample space with outcomes that cannot be counted is an infinite sample space. That means your outcomes could go on forever. An event is a subset of a sample space. So when they're referring to an event, they're talking about what is a specific outcome you're looking for. Now to compare the finite and infinite a little bit more, spinning the spinner, you can see that the spinner has three sections. Those are finite because you can only get a red, blue, or purple. In infinite, there are two different kinds of infinite sample spaces. You've got infinite discrete, which means if you're tossing a coin until you get two heads. The key word here is until. So you do have a final outcome that you're going to get to, but you don't know how long it is to get to that point. And infinite continuous means all the diameters of a circle. That's an example. So this one, you keep going, there's no ending. You end whenever you want to end, but there is no ending for that sample space. Infinite discrete sample space have outcomes that can be arranged in a sequence or counted but go on indefinitely. Infinite continuous sample spaces cannot be counted or defined because there are infinite ways to fill the sample space. So you can represent the sample spaces in three different ways. You can do it as a list, you can write it as a table, or you can draw a tree diagram. Now the tree diagram is one that could be a lot bigger depending on how big your sample space is going to be. So usually you're probably going to either write a list or put it as a table. But we'll practice using all three ways. For example 1, a fair die is tossed once. What is the sample space of the experiment? That means what are all the possible outcomes you could get? So I would have 1, a 2, a 3, a 4, 5, and a 6. Those are the only outcomes I could possibly have. Letter B, what is the sample space for the event of rolling a prime number? And then write those outcomes to complete the sample space. So I'm trying to find the sample space, but these are prime. And remember, prime numbers are all numbers where its factors are 1 and itself. So I only have 1, 2, 3, 4, 5, and 6. Out of those, the only numbers that are prime would be 2, 3, and 5. Moving on to our next example. 2 coins are tossed at the same time. What is the sample space of the experiment? So if we are tossing 2 coins, our possible outcomes could be, so you have 2 coins, so you could get both heads, you could get heads, tails, you could get tails, tails, or you can get tails, heads. Those are the possible outcomes you could get. What is the sample space for the event of the coins landing on different sides? So a sample space where it's different sides. And the sample space for that would be heads, tails, and tails, heads. Example 2, now we're going to represent a sample space. So it says Kemba has a black hat and a red hat. He chooses one hat for each day, Saturday and Sunday. Represent the sample space for this experiment by making an organized list, a table, and a tree diagram. So for the list, so we'll do the list over here. So a list would be, we could have, we'll use B for black and R for red. So you can get a black on a Saturday, black on a Sunday. You could have black Saturday, red Sunday, you could have red Saturday, red Sunday, or you could have red Saturday, black Sunday. So that would be our list. Now Saturday, you have a choice of black and red. Sunday, we have a choice of black and red. This is our table here. So this category would be black, 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 red, red, black, red, red. And then the tree diagram. For this tree diagram, you have our outcomes. So our outcomes are here. So you can either get black or red. Those are your possible choices. On Saturday, you have a choice of either black or red. On Sunday, actually this one would be Saturday, and then this one would be Sunday. And if you chose red on Saturday, you could have black or red on Sunday. So that would be our tree diagram, which at the very bottom you would have BB, BR, RB, and RR. You can see that our outcomes are all the same no matter what organized list you use. Next, Farouk is choosing from the audience to be a contestant on a game show. In the game, one orange token and one teal token are placed in a bag. Farouk draws one, returns it to the bag, and then draws again. Represent the sample space for this experiment by using a tree diagram. So he's choosing from the audience to be a contestant on the game show. In the game, we have one orange token and one teal token that are placed in a bag. So you only have those two in here, so your outcomes. So you can either, your first choice can be orange or you can be teal. So this is the first pick. The second pick, so if you pick orange first, you could do orange second, teal second, or if you chose teal first, you could go orange or teal. So our choices, our samples would be orange, 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 teal, teal, orange, teal, teal. Again, we still have 4 possible outcomes. Next, a geometry teacher always breaks her class up into red, yellow, and blue groups for class projects. Represent the sample space for the next 2 class projects by making an organized list. Then find the outcomes to complete the organized list. So you could have, they're in groups of 2. So we have red, 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 yellow. Then you could have red, blue. You could have yellow, red. You could have yellow, yellow. You could have yellow, blue. You could have blue, red. You could have blue, yellow. And you can have blue, blue. Those are the possible outcomes you can have. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. Example 3, finite and infinite sample spaces. Classify each sample space as finite or infinite. If it's finite, then write the sample space. If it's infinite, then you have to classify whether it's discrete or continuous. So letter A, a marble is drawn from a bag that contains 3 orange marbles, 5 green marbles, and 4 blue marbles. But I think, is there limited options in the bag? And yes, there is a limited, so this one is finite. And the sample space would be, you can either get orange, you could get green, or you get blue. Those are your only possible choices you can get. Letter B, a spinner with 4 equal parts, green, blue, red, yellow, is spun until it lands on yellow. Until is a key word. So until tells us that's infinite. You do come to an ending, so this would be infinite discrete. So you keep spinning it until you land on a yellow. You won't know how many that would be because that would be infinite, but it does come to an end. And letter C, ball is thrown into the air and its height is recorded in inches. Now you can keep throwing the ball up there. It doesn't matter how high or how short. You just keep going. So this would be infinite. And this would be continuous. Next, you record the number of cars that pass your house before you see a black car. So you're going to keep going until you see a black. So this one is infinite. And this would be discrete because there is an ending. We just don't know when a black car will appear. Letter B, you randomly select a person and record the length of their right foot in inches. Now this one, they didn't say how many you are selecting, so we can say that this is infinite, and the length will vary, so this would be continuous. Letter C, you randomly ask 4 people their birth dates. So there is a limit. There's just 4 people, and then whatever their birth date would be. So we would say this would be finite. Because you're not going until you get to a certain date. There's a specific amount in there. Next part is the fundamental counting principle. Fundamental counting principle says the number of possible outcomes in a sample space can be found by multiplying the number of possible outcomes from each stage or event. So a formula to use with this would be you take, if I use like n1 and n2, you use n subscript 1 times n subscript 2. So if you have 2 separate events, multiply them, and that will tell us how many total outcomes you're going to have. So it says Santiago lists the number of sections available for the courses he will take in his first semester at college. How many different schedules could Santiago create for this semester? So we have the sections offered for each of the courses. So that's 6 times 5 times 9 times 4 times 6. If you were to multiply all those together, 6 times 5 is 30, times 9 times 4 times 6. This gives us 6,480. So he has 6,480 ways he could have his schedule created. Next, Phaedra wants to make a playlist with one of her favorite songs from each of the stations listed. If the order of the songs doesn't matter, how many different playlists can she create? We're going to do what is a reasonable estimate for the number of possible playlists, and then how many different playlists can be created. This is a two-part question. So if we were to round our numbers, we can round them to the nearest, 10. So this 19, we round it to 20. This will round to 5. So we'll round to the nearest 5. This would be 20. This would be 30. This would be 10. This would be 20, and this would be 5. So if you did 20 times 5 times 20 times 30 times 10 times 20 times 5, we would get roughly 60 million. Let me try that once again. And actually, we're going to make this, keep this at 25. And if you multiply all of those together, that will give us about 50 million. That would be our reasonable estimate. Now to find the actual, you do 19 times 6 times 21 times 25 times 9 times 20 times 5, and we get 53,865,000, which our estimate is a reasonable estimate. Next one, a sneaker company lets you customize your own sneaker on their website using their most popular sneaker as the base. You have the option to customize the color of each sneaker. What we need to do is find out which is the best estimate for the number of possible customizations, and then find out how many different customizations there can be. So for this one, we'll round these to the nearest 10 here, so we get 20, this will be 10, 30, 10, we'll just keep this at 2, and then this at 30. That gives us 20 times 10 times 30 times 10 times 2 times 30. That gives us 3,600,000. So that would be choice B if we rounded it that way. How many different customizations would there be? So if I go back and did 20 times 12 times 29 times 12 times 2 times 29, we get an answer of 4,844,160. So technically C would be closer to that one, but based on how we estimated their numbers, B would be the correct choice for part A, and then part B we have 4,844,160 different customizations you could create for your sneaker. That is our lesson on sample space.